Hello again, cohort 4. I'm back here, and now in this video, we're going to explore the dependent samples t-test and power analysis with the dependent samples t-test. I want to be very clear that Lab 1 calls the dependent samples t-test by dependent samples t-test. In SPSS, the dependent samples t-test is called the paired samples t-test. And so if you hear me say paired samples t-test, please know that I'm referring to dependent samples t-test and vice versa. The two terms are interchangeable. And so what I would like to do is I'd like to show you that I copied a pre-test score and a post-test score for the same class with the same teacher. I copied the data into SPSS. So what the purpose of a dependent samples t-test is to compare the differences in means between a dependent group, meaning that the two samples came from the same group, and there's a difference in time of day or difference in instruction. Maybe a treatment was done in between, and you're looking to see the effect of the treatment in a post-test. And so you're looking to see if there's a difference between scores in one particular group. And so what I have here is, again, I have pre-test score 1, and then I have the post-test score after them for the same class. So these are side-by-side student scores. So this is student 1, this is student 2, this is student 3, this is student 4, and so on. As you can see, it's a pre-test and a post-test score by student. So in order to run my dependent samples t-test, I'm going to go to Analyze. I am going to go to compare means because t-tests compare means. I'm going to go to paired samples t-test. And then I'm going to put in my information for how I would like the program to read my data. So my pre-test is variable 1, and my post-test is variable 2. The problem says to make sure that we are including an effect size. And so I'm going to include an effect size by clicking the checkbox. Next, I'm going to click OK. When I click OK, it gives me an output. And the output tells me that I have a paired sample statistics, which here in this table, I have my descriptive statistics. My mean for pre-test was 66.109. And the number of students who I have scores for the pretest for was 73. I have a standard deviation of 16.58 with a standard error mean of 1.9. My post-test, the mean actually dropped to 63.6287. I have the number of 73. I have a standard deviation of 18.86, and then I have a standard error mean of 2.2. So there was actually a decrease in the mean between the pre-test and the post-test, but I want to determine if there's a statistically significant difference in the decrease in scores. And so you can also see here that the standard deviation suggests that there was a larger spread of scores, and so more scores were further away from the mean. So there is a paired samples correlations table, but we're not going to use that table for the purposes of this lab, and so I'm going to ignore it for right now. Okay. So you're also going to see a paired samples t-test table. And so the paired samples t-test table tells us the mean, 2.82192. It tells us the standard deviation, 20.02800 for this pair, because remember, this is the descriptive statistics for this pair. So this is giving us that information. We have a standard error mean of 2.34. I have a confidence interval range of -1.8. My upper part of the range is 7.4. I have my t-score of 1.204. I have my degrees of freedom, which is the number -1 at 72. And then I have my SIG two-tailed, which is 0.233, excuse me. So when I look at this and I'm trying to determine if there is a statistically significant difference between the means of the pre-test and the post-test score, I can look pretty quickly at my alpha, and I can see that my p-value is not below 0.05. it is actually above 0.05. So my p-value suggests that there is not a statistically significant difference between the two means. The other area that I could look is if I have my t-table critical t-value chart in front of me, which is actually located in the back of the textbook, I would be able to see that that t-value does not support a statistically significant difference. The other area that I can look to see if there's a statistically significant difference is my confidence interval range. Because my confidence interval range crosses 0, there is no statistically significant difference. This number is a negative 1.8. Well, this crosses 0 because this number is positive. So there is no statistically significant difference between this group. There are 3 numbers in this table that suggest no statistically significant difference. We also have our effect size using Cohen's d, and I can see that there is a weak effect size of 0.14 suggested in the paired samples effect size table. Okay, so that's the basics of the inferential statistics portion of a dependent samples t-test. But now, if we go back to question number 10, it says, given the p-value, sample size, and effect size of your dependent samples test, what is the power of your study? And so it's asking us, with the information that you have on your output, what is the power? Well, we can calculate the power of our dependent samples test by using the power analysis tool under Analyze. So we go to power analysis, we go to means, we go to the paired samples t-test once again, and we're going to use, where'd it go? There it is. Okay, and we're going to use the estimate power option. So this one says estimate sample size. I'm not going to use that one because the question is telling me to answer what is the power of your study. So I need to figure out the power. So in order to figure out the power, I'm going to click on estimate power. When I click on estimate power, it gives me the option to put in the sample size. And so that is a required box for this analysis tool. So sample size would be the number of pairs that I have, number of pairs of scores. Well, that's the number in the descriptive statistics box, which would be 73. So I have 73 pairs of pre-test and post-test scores. Next, it's asking me for the population mean difference. Well, the population means difference was calculated in the paired samples t-test score, or paired samples t-test. So I know that my population mean difference is 2.82. So I'm going to put in 2.82. Next, I have my population standard deviation for the mean difference, which is actually calculated in the paired samples t-test as well, which was 20.02. So I'm going to put in 20.02 as my population standard deviation, or deviation for the mean difference. I am doing a non-directional two-sided analysis, and I have a significance level of 0.05 down here at the box. But the question tells me, says, given the p-value. So I'm going to put in the p-value that I received, which was, where is it? Hang on one second. Whoops. Okay, there we go. The p-value that I received back was a 2.33. So I'm going to put in my significance level of 0.233. I'm going to click OK. When I click OK, it gives me the power. Whoops. It gives me the power of 0.510. And so essentially, if I look at my power, that's a moderate power. Because a high power would be a 0.8. So that is how you find the power of your study, given all of the information from the data output in SPSS. And so let me know if you have any additional questions. You can call me, give me a phone call, or call me, email me, or send me a message through Canvas. I am willing to help. And so I hope that you found this information helpful, and I wish you a really great week, and I will see you on October 31st.